Hello everybody, my name is Greg from GregsTutoringNYC at gmail.com. I am a tutor for mostly elementary school kids, and I am running a bunch of video series right now focusing on grade 7 and grade 8 math. I'm going to run through the New York State test sampler that's online, and let's just jump into it. Just want to make sure this is actually connecting. Elementary school kids, and I am running a bunch of... Okay, all right, it seems to be going. So I'm going to put that down here. And let's just jump into some of this. Okay, so we're going to continue on with grade 7. We're going to do another 10 questions. I think we did about 10. And we're going to do maybe another sampler of this, and like 3 or 4 samples of the grade 8 math, and then see where things lead to. This way everybody has a good idea what's going on. So when you do your New York State test, I'm just going to jump into this at this point. When you do your New York State test, remember some of the first pages has a reference sheet. Okay? So what I'm going to do is jump into the first question right here. Let me just make sure it's showing on my thing here. No, it's not. So here's where we should be. Wait a second. This is... Alright, so the previous page, which was not showing, showed the reference sheet. Okay, it's a standard reference sheet that you get on your math test, so there's nothing surprising here. Okay, so what do we have here? The drawing of a building, shown below, has a scale of 1 inch to 30 feet. So if you caught my other video, what I like to do is not read anything and just look at the picture. So I see a building. It tells me that it seems to implying that the height is 1.25 inches, and there's 0.75 inches there. Okay, so that that must be the drawing of the building shown below has a scale of 1 inch to 30 feet. What is your actual height in feet of the building? Okay, so let me try to get my pencil here. That was working okay before. Let me make it thinner. Something tells me this is not coming through because it's burping. It's starting and stopping. Let me double check this again. No, my phone seems okay. I'm on FiOS, so my stream should be alright, but I just saw it glitching, so I don't know if my audio is coming through right. Okay. And in the event, the drawing of a building shown below has a scale of 1 inch to 30 feet. What is the actual height in feet of the building? Okay, so they're giving us 2 numbers here, this here, and this number here. This is the one we're caring about because that's the height. Okay, so again, it deals with ratios. It's 1 inch, in this case that's inch, to 30 feet. And as we did in the first example of the other sampler, we can also write this as 1 over 30. Okay? So 1 inch is that. We could also do this, and if we set it, so what we have is the actual, we have the scale to the actual. That's our ratio. The scale to the actual. Okay, so the actual. There's 2 actuals, so the actual scale and the actual thing. So 1.25 is to x. So if you do the cross product, we get x. Cross product means multiply this here, and then come back and multiply this here. Some of you also know this is the butterfly technique. And we get 30 times 1.25. You can do that in your head. Half of 30 is 15. Half of 15 is 7.5. So we're going to end up with 37.5. We can double check it on the calculator. Let me get rid of some of this. So we have 30.125. 30 times 1.25, and it gives us 37.5. Okay, so the answer would be the answer there. We're not going to use the information about the 0.75 because that's the width or the length, or depending on how we want to look at this thing. We're not going to knock the building over. We're going to keep it going up and down. So that's its height. What is the actual height in the building? So if every inch represents 30 feet, we know it couldn't be 22 because that's probably dealing with the width. 24 again makes no sense. 40 is just too big. Okay. 1.25 is close to 1, so the actual number is going to be 30 something. We can see that. And the 0.25 scales up to 30 by the 7.5 there. So what I'm trying to get at is we're going to estimate here and then do the actual numbers. So if we did basically 1 times 30, we get 30. So we know A and B have to be wrong. Okay, and then we'll have put C and D. And since it's a quarter, if you kind of run it through in your head, the 40 is too high. So you can make an educated guess here if you wanted to, and I just showed you how to do the calculations. Okay, the next one. Okay, what is the value of the expression below? Okay, so this is just plain old nasty stuff. I mentioned something in the first video. Often there's a choice coming up between fractions versus decimals. I prefer decimals when I can. Sometimes there's some cases where fractions just leap out. Like if the two fractions here, we have 2/5 and minus 3/4, minus 2/5 and minus 3/4. If they were both tenths, it would make it easier because 0.75 is a decimal and 0.4 is a decimal. And we're also not dealing with things like a third. A third is nasty because it's 0.33333333 forever. So it looks like 0.75 is finite, 0.04 is finite, 2/5 gives us 0.4, and 3/4 gives us 0.75. Okay, right? So basically what I'm saying here is that I'm going to convert everything not to fractions. I'm going to convert them to decimals. So this is minus, okay, 2/5 is the same as 4/10. Okay, and this is minus 0.75. So this is no brainer. We could do this in our heads if you want. It's always worth double checking it with the calculator if you're out to use it, or some other technique. Whoops. So, okay, I'm going to have to clear up this thing to use the calculator. So, this wasn't so hard. So, we're going to start out with minus. Whoops, I don't know why it does that. So basically, you have 0 minus 0.75. Now, we have minus a minus. So minus a minus is the same as a plus. So we have plus 0.4, plus 0.4. The first 0.4 is the equivalent of the 2/5, and if we minus minus, we get a plus. And the second 0.4 is the one that's actually written there, the 0.4. Now we have plus a minus 3/4, which means minus 0.75. Okay, and we get minus 0.7, which is B, and I hope that's correct. Let's see, sample 2. Question number 2 is B. Okay, great. One thing about doing these things live is you can make a fool of yourself. Okay, so that's that. Let me just make sure this is running on my phone still. Yes, it is. Okay, good. Question number 3. So it looks like we have some inequalities here. I'm just skimming the answers quick, and they all kind of look the same. So we have 6M everywhere, we have 18 everywhere, plus or minus 18. We have less than 80 or greater than 80. So I'm trying to look for patterns here without even looking at the question yet. So normally this is the case where we have 6M plus 18, 6M minus 18, greater than 80, and then 6M plus 18 and minus 18 greater than 80. So there's a lot of flip-flopping going on here. So let's try to read the question and see if we can deduce or infer or actually explicitly do the numbers. So Addison wants to ride a bicycle more than 80 miles this week. More than 80 miles. Okay, so it's not 80. So that's why none of these are less than or equal to. Okay, she has already ridden her bicycle 18 miles. Which inequality could be used to determine the mean number of miles, M, she would need to ride a bicycle each day for 6 more days to achieve her goal? Okay, so she's starting from 18. She wants to go over 80. Okay, so try to run some of those through in your head. So she has already ridden 18. So she's starting from 18. If every day she rides M miles, and not just every day, but specifically 6 of them, she wants to go more than 80. Okay, so which one matches that? It seems to be C. And if once we get something like this, we're going to pin down the choice. Let me make sure that's correct. Math 7, question 3 is C. Yes. Let's feed it back into the question. Addison wants to ride a bicycle more than 80 miles per hour. 80 miles this week. So that's the greater than 80. She has already ridden 18, so that's the plus 18. And which can be used to determine the number of miles she needs to go for 6 days. So if M is the average number per day, and there's 6 days, so the amount she's gone is, because she already started with 18, it's 6M plus 18. And she wants to do over 80. So it's jiving, it's making sense. Okay, question 4. Okay, this one deals with probability and statistics, the section of math, again, involving things like that. It also deals to me with reasoning and logic. Okay? A school principal wants to determine which type of speaker the students prefer to invite to an assembly for the entire student population. Which survey method would produce the best representational sample? So first of all, notice that best is in boldface. So there might be multiple answers here that technically are valid, but there's one that's just superior. Now, without looking at the answers, what they normally do is there's one there that's ridiculous. And what they also do is give one that could be useful, like they may ask the parents, or they may ask like the school cafeteria staff, or something like that. Or they may ask like just the second graders only, or something like that. But the best answer here, if you think it through, is asking everybody as much as possible. Okay, so let's just read through some of the examples, okay, and see which seems to make sense. Okay, survey every 5th person who shops at a mall. Okay, that could make sense to the extent that if they went on a class trip that time, or this is just random number of people, you could argue with it's a random number of people in the school. The problem with A is that random number of people is not the people in the school. It's too broad. It's too general. Okay, we're trying to determine what the students prefer. We all know different races of people, different ages of people, different genders of people, all have different feelings, and some of it's stereotyping, but the actual people to ask what they prefer is the population itself. So A doesn't match that. Survey all the students on the student council. Well, that makes sense when you think it through, to the extent that probably the student council got elected by their classmates, and if they're a democratic republic, then the student council would be voting as per the students. The problem is, we know in the real world that things that, like having elected representatives, don't exactly match up one-to-one with the constituencies. So that's why B is no good. So there might be only 3, 4, 5, 7 people on the student council, but if there's like 1,000 kids in the school, it's hard for them really to be representative of that. Survey every 10th student entering the school one morning. That seems to work. All the kids had to be in class at a certain time, and if we do every 10th kid, it's kind of random, instead of taking asking every single kid. So far, C seems to be the best answer. And D says survey all the students who went to the last basketball game. Basketball games in a lot of schools are popular, and at least they're not asking the parents here. In the case of, say, A, it was just random people. In the case of D, it's actual students who actually go there. Okay? One of the problems with D, though, is that it may be sports enthusiasts. So if you go back to the question, it's about who they want to invite to the assembly. The people from the basketball game may want a basketball star there. So that's kind of getting biased and slanted. So the best answer is C. Okay? So again, this is a different kind of math, dealing with logic and reasoning and things like that. Okay? Okay, what do we have here now? The elevation at ground level is 0. An elevator starts 90 feet below ground level. After traveling for 15 seconds, the elevator is 20 feet below ground level. Which statement describes the elevator's rate of change in elevation during this 15 interval section? Okay, so there's a lot of things being flopped around here. So why don't I bring up my trusty pencil? And let's try to see what we got going on here. Basically, we have a number line. Okay, this is ground level. Let me just make sure this is running properly. Yes, it is. Which is 0. We kind of think of this as a thermometer problem too. Instead of a number line, we're going up and down on something. There's an elevator involved here. Okay, so let's take it a sentence at a time. The elevation at ground level is 0. So I put that here. That's the G and the 0. That looks like the word go, but it's not. Okay, an elevator starts 90 feet below. Let me just make sure this is coming on the screen. Yes, it is. Okay. So an elevator starts 90 feet below ground level. After traveling for 15 seconds, the elevator is at 20 feet below. And it does this part in 15 seconds. Okay. Which statement best describes the elevator's rate of change in elevation during this 15-second period interval? Okay, so if we just read it goes A, B, C, D, and we notice it does this flip-flopping back and forth again. So it's either going up at 6 or 4 2/3, or down at 6 and 4 2/3. So how do we figure that out from the numbers we have? Well, it seems like if it's going from minus 90 to minus 20, it's going up. So it cannot be C or D. Okay? And so the question is, how do we figure that out? Well, it's gone 70 feet. So what we're going to do is take 70 and divide it by 15 and get its speed. Oh, wrote that wrong. 70 divided by 15. So be careful with your calculators. So you get 4, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6. Okay, and 6, 6, 6, 6, 6 is 1/3 is 3, 3, 3, 3, 3, 3. So 2/3 is 6, 6, 6, 6, 6, 6, 6 forever. So that's 4 2/3. So it's going up at a rate of 4 2/3. Let's see, we have 5 is B. Yes, the answer is B. Okay. Okay, question number 6. Which expression represents the product of 3 and 15/4 n plus 1.8? Ah, yes. Here we go. Everybody remember their old rules here? All right. So this is the distributor property. If everybody remembers, you know what? Let me try to bring this notepad up thing here, and let me see if it pops up properly, because this might be simpler than that red line thingy. Okay, yes, that's showing. All right, so let me go back to that. So the distributor property is A times B plus C equals AB plus AC. So in our case, we have 3 times 5/4 n. This doesn't mean 4 times n. Let me do this. Plus 1.8. So we have 5/4 n like that. Okay. And what we're going to do is we're going to do the A. So A is 3. C is 1.8. MB is 5/4 n. Okay, again, that's not being written right. 5/4 times n like that is better probably. So let's spit it out. So we're going to get 3 times 5/4 n right? So that's A times B, and then we're going to get 3 times 1.8. Okay, and that's going to become 15n over 4. Sorry, I wrote star there, that should be plus. Plus 5.4. 1.8 times 3 is 5.4. You can do 1. 3 times 1 is 3, and 3 times 0.8 is 2.4, so 3 plus 2.4 is 5.4. Okay, so just based on that, we know the answer is D. And anyway, we have 15/4 n. Okay, 15/4. Where's my cursor? Why is that not moving? Something's not right. I don't know why that's not moving anymore. Okay, there we go. Something was delayed. So 15/4 is the same as, if we do it a whole number, we get 3 and 3/4, right? 4 times 3 is 12, plus 3 is that. And that's the same as 3.75. So it was 15/4 n, so it's 3.75 n, plus coming back to a plus 5.4. Okay? So that gives us D. Question number 6, let me just check that I'm not making a fool of myself here. Yes, it's D. Okay, question number 7. All right, again, I'm going to look at the chart first. In this case, it seems to be a for sale sign, or a sale sign. Discount, buy 2 shirts, get 50% off a 3rd shirt. Okay, interesting. So if I spend $1 for a shirt, again, I'm just not going to look at the question, not the top, not the bottom. Just going to look at the illustration. So if I buy 2 shirts, let's say they're $1 each, that's $2, and it's telling me the third shirt is $1, is 50%. So that'd be 50 cents. So if I got the 3 shirts, I would have 1 plus 1 plus 50 cents is $2.50. Okay? So Kai wants to buy 3 shirts, which were originally priced $49.69 each. The store will discount the price of the third shirt and then applies 7.1% sales tax to the total cost of the 3 shirts, including the tax. What will be the mean cost of each shirt? All right, so this is a nasty one. This should really be a show you work problem because there's a couple parts to it. So, all right, let's bring the notepad thingy back up here. Okay, so what it means is you're going to buy 2 shirts at $49.69. Let's get rid of this for a second again. You're going to buy 2 shirts at $49.69, and the third shirt is going to be half of $49.96. Sorry, I said $49.69. I meant $49.96. The store will discount the price of the third shirt and apply the tax to the total cost of all 3 shirts, including the tax. Okay, so what we're going to have is the shirts, and then when that's done, a 7.1 tax to the total cost of all 3 shirts. So there's a couple of ways to do this. What we're going to get is 49.96 plus 49.96 plus 49.96 divided by 2. So that's the cost of the first shirt, the cost of the second shirt, and the cost of the third shirt is 50% off, which means it's half. Okay, what we're going to get is, let's bring up our trusty calculator. So we can get 49.96. I'm going to do it backwards just to make the calculator use easier. So I'm going to get 24.94 plus 49.96 plus 49.96. Okay, and that gives me 124.9 if I did it right. Okay. Another way to look at this whole thing is that if a shirt is 49.96 and I'm getting 2 whole shirts for the full price and then a third shirt at half, I'm actually getting 2.5 times the price. So if you just run it through the calculator just to verify that number, we're going to get 49.96 times 2.5. Okay, and we still get to 124.96. Okay, now it's telling us that the tax is going to be 7.1%. So there's a couple of ways to write 7.1%. One is 0.071. Okay, and that would be our tax. The other thing we can do is, because it's saying it's the cost plus that, what we can do is take the 124.9 and multiply it by 1.071. 124.9 times 1.071. Okay, and we get the 133 there. Okay, which is the cost of all the shirts plus the tax. Okay. So if we go back to the question, let's make sure. Let's drag this down. Can I drag that down? It's not letting me drag that down. Come on. Hopefully it saves us. Let me see. Okay, including the tax, what would be the mean cost of each shirt? So it seems to me that if we come back to the calculator and divide by 3, we're going to get 44.58, which rounding up into dollars and cents gives C. Question 7 is C. Thank God. Okay, so we get C. All right. So just to go over that again, 100% of something. Again, if we go back to what a percent means, it means over 100. So 100% of something is 100 over 100, or 1. So that's why it's a whole. So if the tax is 7.1%, on top of that, it's 100% of the original price plus 7.1%. Okay, and 7.1% is 0.071, then 100% plus 7.1% is 1.071%. Okay? You could have done it the other way, where you took the tax, the number I got before, the 124. In fact, let's do that just to show you that there was another way. The 124.9 times 0.071 gives us the 8.86. And if we take that and add it to, wait, why is the notepad ended up way up there? Why? Okay, the 124.9. This is calculators messing with my brain here. So we're going to get the 124.9 times 0.071 and add that to 124.9, and we still get the 133 like we did before, and that's the price of all the shirts. Now with the tax, if we divide that by 3, we get the 40.59 as well. Okay, and everybody lived happily ever after. So that would still give us C. Okay, question number 8. Again, we're just going to look at the table. We're going to ignore the questions for now, and we're going to ignore the answer, and we're going to ignore what they're even looking for. We just want to try to understand the table first, and then we'll work things out. Okay, so just, by the way, this is a 2-point question now. So I'm looking, this tutoring participation. It's telling us here. Let me bring my highlighter. That's what this seems to be telling us it's about. Wait a second, is that working? No. Number of students. Okay. And the subject. So it seems like it's telling us, without knowing about it, 40 kids got math tutoring, 47 got English, 58 got history. What I normally like to do sometimes is add up these numbers. Those look nasty enough that at the moment I'm not going to. And I'm going to guess it's going to ask us something like, what's the percent of something? So, for instance, all those numbers added up to, say, 200, and it wants the percentage of how many kids took math. It'll be 40 over 200, which is the same as 20%, okay? So now that we kind of looked at it, we're understanding more about what the chart's about. Let's see how the table helps us to complement the words. Again, we're going to take a sentence at a time. An after-school program offers tutoring for different subjects. Okay, I'm assuming that's the math, science, history. During the last month, a teacher recorded the number of students who participated in tutoring in each subject, as shown in the table below. Okay, so this is the number of students. We don't know what grade. We don't care. It's not looking at that at the moment. So it was what I said earlier. 55 students took science during that month. Okay, explain how the teacher could use these data to predict about how many of the next 100 students will participate in math tutoring. So this is more or less what I just said. So what we need to do is add up all the numbers. 40 plus 55 plus 47 plus 58 equals, you can do this in your head and then double check it with the calculator. So what we're going to do is add up just the tens numbers first. 40 plus 50 is 90, plus 40 is 130, plus the 50 is 180, and then I'm going to add the 888 plus 12 is 100. I think it comes out to 200. I'm going to double check it on the calculator. So 40 plus 55 plus 47 plus 58. Okay, it's 200. I like to use numbers backwards, so I'm going to round up the list backwards. 58 plus 47 plus 55 plus 40 also gives me 200. Okay, so now I know that there's 200, at least in the month she talked about here. How many kids were there? So the question is, how many will participate in math the next time? Well, there was 40 out of 200 for that month. So we can do a division and get a thing, or we could just divide both by 2, because that's the same as 20 over 100. That's equal to 20%. Okay, or we could just done it with a calculator. This is still the same way. If we do 40 divided by 200, we get 0.2, which is the same as 0.20. Okay, which is the same as 20%. So we still get the same answer. So if we come back to the question now, have we answered it? Okay, it just wants an explanation. Let's see if there's any other part of it. Okay, there's no other part. So you're going to get 2 points, and that seems to be what they're looking for. What I like to do is run through the whole question again, just to make sure I covered every part. An after-school program offers tutoring for different subjects. During the last month, the teacher recorded the number of students participating in subject. Good. Explain how the teacher could use these data to predict about how many next. Okay, so we don't know. It's 20% as a prediction. Okay, because the measurements didn't happen. We're using the previous month's measurements. Again, this deals with probability and statistics again. All right? Okay, so we're going to go to the next question. Let me just make sure this is okay on my phone. Yes, it seems to be. So, a home improvement store sold wind chimes for $30 each. Okay, so we're going to take this a sentence at a time. There's $30 wind chimes. A customer signed up for a free membership card and received a 5% discount off of the price. So it seems to me that the customer bought a wind chime that was $30, and the free membership card entitles them to receive 5% off. So it's going to be 5% off of 30, okay? And it's going to be some other number. Before the person leaves, a sales tax of 5% was applied after the discount. What was the price, the final price of the wind chime? Okay, it's intuitive to say, well, 5% was taken off, and 5% was added, and minus 5 plus 5 is 0. Unfortunately, that's not the way percents work. A lot of kids get this wrong. It seems intuitive. Wait, there's 5 here and 5 there, but you're dealing with two different numbers. Let's imagine it was 10%. If it was $30 for a wind chime, if it's 5% off, sorry, let's say it's 10%, it's going to be $3 off. That's $27. So the 5% sale tax is going to be based on $27. But the 5% discount was based on $30. So the two numbers don't match up. Will the number go close to 30? Yeah, but it's not going to be. So basically what we have to do is we're going to have $30 times the 5%. Okay? And that's going to be the price that's charged. Another way to look at this is we have $30 times 0.95, because we're going to take 100% and subtract the 5 off it, and that's going to give us the price after the 5% discount. All right, because what we could do is do the 30 times the 5 and then subtract it off of the 30, which is going to be I guess $1.50. So the price is going to end up being it should end up being $28.50. Okay, and let's check that on the calculator. So we have 30 times 0.5 is $28.50. Okay, so that's going to be the price after the thing. Now what we're going to do is take the $28.50 and multiply it by the 5% added to it. So again, we could do this in 2 steps. We can get the 5% and add it to the $28.50, or we can say it's $28.50 times 1.05. So it's the whole thing plus the thing added onto it. So times, whoops, that should be equal the price with the sales tax. So if we come back to the calculator, times 1.05, and we get 29.925. And since this is dollars and cents, we get 29.93. And we need to fill it into our answer here, like that. Okay, most of you using paper things. There was only a few schools in New York City that use it. It was actually about 25% in the whole state, and a number of them ran into problems. So in any event, the goal of this is not to show you how to do this online. That's just to help me show you how to do this more conveniently through YouTube. The goal is to get the right answer. Okay, so let me just get rid of the calculator for a second. And what I do is, now that I have the answer, I'm going to feed it back into the question and see that I've really addressed it and I didn't make any mistakes. I've definitely shown my work, assuming it's correct. I filled in my answer. Again, on a real paper, you need to do both of these still. This is a two-part question. Really, the answer doesn't give you a point. The whole thing does. So you want to get points for the procedure, for understanding the question, for using the right equations and so on. And then obviously you're going to get a point for the wrong answer. If, for instance, you made a mistake with that 29.925 and put 29.92, then you're still going to get a point off, even though you worked through the whole thing getting it right and trying to understand it. All right, so let me just take this a cents at a time and feed it back in and make sure it's all good. A home improvement store sold wind chimes for $30 each. Fine. A customer signed up for a free membership card and received a 5% discount off of the price. Okay. Sales tax of 5% was applied after the discount. Okay, yes. And by the way, there's an alternate one here, which is that if you take $30, okay, multiply it by the price after the discount, and then that's the new price, and you multiply that by 1.05. Okay, that should also be the price after the discount and after the sales tax. So let's bring our trusty handy dandy calculator back up and run it through real quick. 30 times 0.95 times 1.05 is 29.93 again. Okay, when we round to the dollars and cents. And as they say, they lived happily ever after. Okay, and this is just another way to double check things. There's often multiple ways to do stuff, and this is one of the ways. There's also the ways, by the way, if you come to lines like this one here, and this one here, the ones with the X's, we could have taken those temporary numbers and added them back in. I just find that tedious myself, but if that works for you, that's a perfectly viable way to do this. Okay? All right, question number 9. Now question number 10 is a couple parts here. So this is worth, I'm going to say 3 points. So what I'm going to do again is I'm not going to read the questions. I'm just going to look at the table. It talks about Ruby's market prices. Okay? Just going to look at the table. Ruby's market prices. There's certain kind of meats and there's certain price per pound. Okay, this is no brainer. So if I get a pound of turkey, it's $3.25. If I get 2 pounds of chicken, it's $5 because it's $2.50 a pound. Okay, the question is, okay, so Ruby's Market sells smoked meat by the pound. I'm going to come read it by a sentence at a time. The price for several different meats are shown on the table. Okay, no brainer. This is a fairly simple table. Okay, how much more does 1 1/4 pounds of beef cost than 1 1/4 pounds of turkey? So this is another one of these where I could stay with the fractions. 1 1/4 is the same as 5/4, and if it's a pound of beef, I could do 5/4 times 4.25. It just seems that making that a quarter into 0.25 is going to be helpful for me. So in other words, I'm going to figure out 1.25 pounds of beef times 4.25 equals what? So let's bring our handy dandy calculator back up. So we have 1.25 times 4.25, and we get 5.3125. Let's just make sure that really makes sense. we have 4 1/4 times that, and you know what? I'm going to do my normal thing, which is doing things backwards. 4.25 times 1.25, and I still get the same number. So this applies for, whoops. I don't know why it's doing that. Let me get rid of the calculator for a second. Let me get rid of the highlighter for a second. This is the beef. 1 1/4 pounds of turkey equals 2.85, and that's equal, so this is going to be the turkey. So let's bring the calculator back up, and we have 2.85 times 1.25, and let's just do it backwards again. 1.25, nope, 1.25 times 2.85, is that the number in the table? So we get 3.5625. 3.5625. That's to turkey. Now we could have rounded these because this gives us 5.31, and this gives us 3.56. I got a 3.56. And it's saying how much more does it cost. So how much more means difference. Difference means subtraction. Okay, so we're going to get 5.31 minus 3.56. Okay, whoops. Okay, you can do this in your head. I would suggest you do, and then use the calculator. So we have 5.31 minus 3.56, and that did not work. Okay, let's clear that. So I typed that wrong. Minus 5.31 minus 3.56, and we get 1.75. Okay, and it says how much more. So we have to put our units. So we go back and we have dollars. Only one of them, obviously. All right, let's go to the calculator. Okay, so that's that. So, okay, wants it here. So 1.75. Okay. Brad has $10 to spend at Ruby's. So he orders half a pound of sausage and 1 1/4 pounds of chicken. So sausage is $3.25. So it's going to be half of 3.25, or 0.25 times 3.25 for the sausage. And the chicken is going to be 1.25 times, the chicken is going to be what? 250. And then the question is what? How much money will Brad have left there if he pays for the order? Okay, so we're going to bump those through the let's see. Oh, 1 second. I got a text from somebody. I have to answer it. Let's bring up the calculator again. It's not bringing up the calculator. Where's the calculator? It's up there. Can I drag that down? Yes, I can. So we have 3.25 divided by 2. That's 1.625, and we have 1.25 times 250. So that's equal to 1.625, or in dollars and cents, 1.63. This is 1.25 times 2.5 equals 3.125, or in dollars and cents, 3.13. And if we add the two of them together, so we're going to get 1.63 plus 3.13, and we get 4.75. Sausage plus chicken costs 4.76. Okay, and he started out with $10. So we're going to have $10 minus 4.76. That's going to be what? $5.24. What we can do is subtract 10 from here. Minus 10 will give us a negative number, right? $5.24. So that should be our answer, $5.24. Let me just spit that back in to see if I actually did the numbers right. He has spent $10 at Ruby's. He has a half a pound of sausage, $3.25. Let me see if sausage is actually $3.25. Yes, it is. Half of that is about 1.63. Yes. Chicken is $2.50. Yes, and he has a pound and a quarter of that. Yes, he does. And that's about $2.50 plus about a quarter of that, so it's about 3.13. Good. Add them together, 3, 4, get about $5, which is $4.76. And subtract it off the 10 and we get $5.24. Okay. And then in this case, it would want us to submit it. I've answered all the questions, and we are able to get through one of these other tests again. So what I'm going to do is stop again and do another part 3 at some other time. Hopefully everybody is enjoying this. Again, I'm Greg at GregsTutoringNYC at gmail.com. I've been tutoring for decades. I enjoy helping kids. This is a lot of fun to me. And I like making sure everybody's up to date on the state tests. And the SHSAT, I tutor for specialized high schools. I do the SHSAT, Hunter, Baccalaureate, Beacon. I help kids with writing. I help kids with the ELA test, all the different parts, even the science test, through all the boroughs. I even do it in New Jersey, Connecticut, Westchester, Long Island, which is most of this applies to. My voice is getting screwed up here, so I want to wish everybody a good day. If I don't do the part 3 now, I'll do it tomorrow, probably. In the meantime, peace out.